This lesson is on exponent laws. I will be splitting this lesson up into two parts, one part for the lesson and the second part for the examples. If you see an example below that is similar to the question you're working on, feel free to download my app referenced in the video caption. You can use my app to quickly navigate all of my Math 10 lessons and examples. So you can use it to go directly to the below example, one of the below examples within my lessons. For this lesson, I highly recommend you look at the lesson component as well, though, because these exponent laws can be cumbersome to memorize and remember for your test. So I actually show you ways to derive quickly, i.e. figure out quickly what the exponent laws are if you have forgotten what they are. So let's do some exponent law review. This one is called the product of powers. You can see we have a to the m multiplied by a to the n. This is going to equal a to the m plus n. So what we describe this as, you can see we add the exponents. We're multiplying two exponents with a common base. So anytime we multiply two exponents with a common base, the base is the a here, you add the exponents. Let's look at a quick example. Evaluate a to the 5 times a to the 2. That's just going to be a to the 7 because you add those exponents. Now, what if you can't remember the exponent law, or it's not on your formula sheet? You can figure it out by doing a simple example for yourself and by simply expanding, canceling, and counting. So the steps that you use to figure it out yourself are very straightforward, very simple. You don't need to memorize much for just doing a simple example for yourself and figuring out what the law is. So what do I mean by this? Let's look at a cubed times a squared. So this is just a simple example. You would think of yourself, use low numbers in the exponents there. And so what we do as a step one is expand. Expanding here is quite easy. A cubed is just 3a's. So basically you rewrite it without any of the exponents. You just write out the number of variables instead. That's why you want to pick low exponent values. So 3a's and a squared is just 2a's. Step 2, just count. So we have 1, 2, 3, 4, 5. There are 5a's. And then we can rewrite that as a to the 5. And step 3, look back to see what you started with. We started with a cubed times a squared, and what you ended up with was an a to the 5. So you can figure out what exponent law was used. So when multiplying exponents with a common base, the a is the base again, we see that we add those exponents. We had a 3 and a 2 here, we ended up with a 5. Well, there's only one thing that could have happened here. We needed to add those. So this is an example of how you can figure out the law for yourself. And I highly recommend, if you forget these laws on your test, even if you think it's simple and you remember the law, if you're not 100% sure, just do yourself a quick example. This does not take long to do, right? And I will actually show this on every single one of the exponent laws we do in this lesson. So quotient of powers, a to the m divided by a to the n. This is similar to the multiplication of powers, except it will be m minus n. So your answer is just, in this example, a to the 15 over a to the 12. You do 15 minus 12, and then that'll be a 3. Say your 15 was on the bottom and your 12 was on the top. Well, then you could do 12 minus 15 and get negative 3. That's fine. But then it's actually standard practice to not leave a negative exponent in your answer. So you would rewrite that as 1 over a to the 3 if you remember one of the previous lessons. Or if you had 15 on the bottom, 12 on the top, you can just take the bigger number, 15, on the bottom minus 12 on the top, and you're left with 3 on the bottom. So 1 on the top and a to the 3 on the bottom. Again, if you can't remember the law, figure it out by doing a simple example for yourself and by simply expanding, canceling, and counting. So let's pick low numbers again. A to the 5 on the top, a to the 3 on the bottom are low exponent values here, so that when we expand it out, we don't have to write too many a's. Now we expand it out. Step 2 is cancel. And then step 3 is count. How many are we left with? So remember, whenever you cancel something, basically you're replacing it with a 1. So we're left with the 1 times 1 times 1 on the bottom, which is just a 1, and then a 1 on the top to do with these 3 a's, and then we're left with 2 a's on the top. So we're left with just a squared in the numerator divided by 1. Of course, we don't need to write our 1 on the bottom there. So look back to see what you started with, a to the 5 over a to the 3, and what you ended up with, an a to the 2, and you can see, 5 minus 3 is what the law was, and you end up with a 2 in the exponent in your answer. So that's how you figure out the quotient of powers exponent law. So the power of a power, a to the m to the n. You multiply those exponents. Looking at an example here, a to the 4 to the 8, that'll be a to the 32. Again, if you can't remember the law, figure it out by doing a simple example for yourself. A to the 3 to the 2, again, picking small numbers here. No, don't pick the same number though, because sometimes it's not as obvious what the law was then. If you had a squared to the 2, you could have 2 plus 2 is 4, or 2 times 2 is 4. So definitely don't use 2 2's. It's typically a 3 and a 2, or like an odd number and an even number will work. Just keep them low so that when you expand, you don't have to write too many a's out. So a to the cubed is just 3a's, and then squared is that multiplied by itself. And we count those a's, and there are 6. So we see, okay, 3 and a 2 is what we started with. The only thing that could have happened there is you multiplied them together to get the 6. So you figured out the law. AB within brackets to the m. So this is power of a product. Our product is a times b. The law at play is where you apply the exponent to each thing on the inside. So the m applies to the a and the m applies to the b here. Let's evaluate a times b to the 8. That's just going to be a to the 8 times b to the 8. Again, if you can't remember the law, figure it out by doing a simple example for yourself and by simply expanding, canceling, and counting. So let's do ab to the 3. And so that's just AB multiplied by itself 3 times. Now count how many A's and how many B's. There are 3 of each, so we're left with A to the 3 times B to the 3. And so what did you start with and what did you end with? You can see that exponent there applied to both the A and the B on the inside. And this would apply to if you had a fraction inside too. The 3 would say AB divided by C. The 3 would go to the A, to the B, and to the C on the bottom. Let's look at the power of a quotient. So this is the one I actually just alluded to. A divided by B to the m. This is just A to the m times B to the m. So that m, again, exponent, applied to the A and the B. Basically, just remember, if it's an exponent on the outside of the brackets, it applies to everything on the inside of the brackets, including numbers. If there was a 2a on the top here, it would become a 2 to the m times a to the m over b to the m. So let's evaluate a over b to the 8. You apply that 8 to both the a and the b there. Again, if you can't remember the law, figure it out by doing a simple example for yourself and by simply expanding, canceling, and counting. Let's use a 3 as our exponent here, and I'm using a over b again. So this is just a over b 3 times. Count the a's and the b's. You have 3 on the top, 3 on the bottom. So a cubed on the top, b cubed on the bottom. You can see that you started with a 3 On the top here, a over b to the 3, and then that 3 applied to both the top and the bottom. So that was your law there. So the examples get relatively complicated, so that's why I will split the examples up into a part 2 of this lesson. So see you in part 2, and remember, as I mentioned at the beginning of this lesson, you can download my app to quickly go between all of my lessons and all of my examples.